Hello everyone. In the last video we learned about half adder and half subtractor. In today's video we are going to study about full adder. In half adder there is one disadvantage. In multi-digit additions using half adder, we were able to add only two bits at a time, and the third bit, which was considered to be the carry of the previous addition. Say for example, if I want to add numbers like this 1 1 0 1 ಈ ಥರ ಹಾಫ್ ಆ್ಯಡರ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು if I want to add 1 plus 1 is nothing but 0 with carry 1. When I am using a half adder can add only two bits at a time, whereas here in this particular case I am having three bits, so I cannot use half adder. ಇಲ್ಲಿ ಹಾಫ್ ಆ್ಯಡರ್ನ ನಾನು ಯೂಸ್ ಮಾಡೋಕೆ ಆಗ್ತಾ ಇರಲಿಲ್ಲ ಬಿಕಾಸ್ ಹಾಫ್ ಆ್ಯಡರ್ is having the capability to add only two bits at a time, leaving the carry which is generated from the previous addition. So ಈ half adder na usual ಆಗಿ we were not using, practice ಅಲ್ಲಿ ಇರಲಿಲ್ಲ, we were not using that. But whereas this full adder is a combinational logic circuits which will be having three inputs and two outputs. Three inputs will be named as A, P and C in. So what is this C in? ಇವಾಗಷ್ಟೇ ಬರ್ದಿದ್ನಲ್ಲ ಅದೇ ಎಕ್ಸಾಂಪಲ್ ನ ತಗೊಳ್ಳೋಣ. 1 1 0 1 ಏನೋ ಹೀಗೆ ಬರ್ದಿದ್ದೆ ಅನ್ಕೊಳ್ಳಿ. 1 plus 1 is 0 with carry 1. This particular one can be considered as A and this can be considered as B, whereas this is the carry which is generated from the addition of its lower significant numbers. So lower significant numbers in the bandiruvanta carry na we are going to represent as C in, carry input. ಇಲ್ಲಿಂದ ಬರ್ತಾ ಇರುವಂತ ಈ ಅಡಿಷನ್ಗೆ ಈ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಲೋವರ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಬಿಟ್ಗೆ ಬರ್ತಾ ಇರುವಂತ ಇನ್ಪುಟ್, ಸೊ ಅದನ್ನ ಕ್ಯಾರಿ ಇನ್ಪುಟ್ ಸಿ ಇನ್ ಅಂತ ನಾವು ಶಾರ್ಟ್ ಆಗಿ ಕರಿತೇವೆ. ಸೊ ದಿಸ್ ಫುಲ್ ಆಡರ್ ಇಸ್ ಎ ಕಾಂಬಿನೇಷನಲ್ ಲಾಜಿಕ್ ಸರ್ಕ್ಯೂಟ್ ವಿಚ್ ಆಡ್ಸ್ ತ್ರೀ ಬಿಟ್ಸ್ ಅಟ್ ಎ ಟೈಮ್, ಗಿವಿಂಗ್ two outputs which is called as sum and carry. When we are going to tell that it is having three inputs, so how many different combinations will be having? 2 to the power of 3, which is equal to 8 different combinations, and those 8 different combinations I have already written on the board. So the very first case 0 0 and it is 0 0, 8 different combinations means it is from 0 to 7, that I have already written on the board. This is 0 1 2 3 4 5 6 7. So totally from 0 to 7 I am having 8 different combinations, and finally we'll be getting two outputs. One is called as the sum, the other one is called as the carry. Now let us see one by one what will be the sum as well as the carry value when we are going to add these combinations of numbers. When I am going to add three zeros, sum will also be 0, carry will also be 0. There will be no sum or carry. When I am going to add 0 0 1, when I am going to add this, I am going to get a sum of 1. No carry will be generated, so carry part will be 0, sum will be equal to 1. Similarly 0 1 0 anta helidagu, when I am going to add, the sum part will be 1, there will no be carry generated over here, so carry is equal to 0, sum is equal to 1. When I come to this case 0 1 1, when I am going to add this, 1 plus 1 is 2, then I am going to write it as 0 with a carry of 1. So this is the sum part and this is the carry part. This is the sum part and this is the carry part. So carry is equal to 1, sum is equal to 0. 1 0 0 andre sum is 1, carry is 0. I am having two number of ones, sum is 0 with a carry 1. I hope you are understanding. 1 1 0 0 with carry 1. When I am going to add three ones, I am going to say A value is 1, B value is 1, C in value is also equal to 1. So 1 1 1 it is equal to 3, that we are going to represent as 1 with a carry of 1. Sum value is also equal to 1, carry value is also equal to 1. So 1 1. Like this we are going to write the truth table of a full adder for 8 different combinations. Now we are going to see how to construct a full adder using two half adder circuits. For a half adder, I will be having two inputs which will be named as A and B, it will produce two outputs. One will be called as sum, the other one will be called as carry. Here I'll be having another half adder. But for this half adder, one input will be given from the sum of the previous half adder. But since I am constructing a full adder, I have to give another input which will be called as Cin, and that will be given as second input for the second half adder. Let me call this as the first half adder and this is the second half adder. So this is the second input for the second half adder. This carry, and it will also produce two output. One is sum, the other one is carry. This carry as well as this carry will be given to an OR gate to get the carry part, whereas this is the sum part. So this entire thing, this particular thing gives you one full adder. So like this, I am going to use two half adders in order to construct one full adder. Now let us try to understand what will be the expression for the half adder and full adder. So half adder nalli some part ge expression was A, X or B. And for the carry, I am talking about half adder. Let me write it as HA. HA stands for half adder. Carry ge ಏನಿತ್ತು expression A dot B ಅಂತ ಹೇಳಿ. In the last videos itself, I already told you, we are going to write the expressions in such a way that ಎಲ್ಲೆಲ್ಲಿ ನನಗೆ ಔಟ್ಪುಟ್ಸ್ ನಲ್ಲಿ 1 ಅಂತ ಇರುತ್ತೋ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಬಿನೇಷನ್ಸ್ ಇನ್ಪುಟ್ ನ ತಗೊಂಡು if its value is equal to 0, we are going to write it in complemented form. If its value is equal to 1, then uncomplemented form ಬರಿತೀವಿ ಅಂತ ಆಲ್ರೆಡಿ ಹೇಳಿದೆ. ಸೊ ಆ ತರ ನೋಡಿಕೊಂಡು ಇವಾಗ ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ನ ಬರಿಬೇಕಾಗುತ್ತೆ. Now we are going to see how to construct a full adder circuit using logic gates. ಒಂದು ಹಾಫ್ ಆಡರ್ಗೆ ನಾನು ಇಲ್ಲಿ ಫುಲ್ ಆಡರ್ ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಎರಡು ಹಾಫ್ ಆಡರ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು we can construct a one full adder. Now for one half adder, I want one XOR gate as well as one AND gate. ಹೌದಾನೆ? ಸಾರಿ. ಸೊ ಇವಾಗ ಈ ಥರದೇ ಸರ್ಕ್ಯೂಟ್ಸ್ ನ ಎರಡು ಸೆಪರೇಟ್ ಹಾಫ್ ಆಡರ್ಸ್ ನ ಬರೆದು ಅದನ್ನ ಲಿಂಕ್ ಮಾಡಿ ಲೆಟ್ ಅಸ್ ಟ್ರೈ ಟು ಗೆಟ್ ಒನ್ ಫುಲ್ ಆಡರ್ ಸರ್ಕ್ಯೂಟ್. ಸೊ ಹಿಯರ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ A and B as inputs for this XOR gate. Then the expression will be A XOR B, which is the sum part. Idardu carry part A. This is a jump. ಇದು ಜಂಪ್ ಅಂದ್ರೆ ಈ ವೈರ್ಗೂ ಯಾವುದೇ ರೀತಿ ಕನೆಕ್ಷನ್ ಇಲ್ಲ. ಸೊ this is this one. This is the carry part. Now ಆ ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಬರ್ದಿದ ಪ್ರಕಾರ let me write it again. This is the half adder A B sum ಏನ್ ಮಾಡಿದ್ವಿ, ಇನ್ನೊಂದು ಹಾಫ್ ಆಡರ್ಗೆ ಕೊಟ್ಟಿದ್ವಿ. ಈ ಸೀನ್ ನ ಇದಕ್ಕೆ ಇನ್ಪುಟ್ ತರ ಕೊಟ್ಟಿದ್ವಿ. ಇಲ್ಲಿಂದ ಬರ್ತಾ ಇರುವಂತ ಕ್ಯಾರಿ ಔಟ್ಪುಟ್, ಇಲ್ಲಿಂದ ಬರ್ತಾ ಇರುವಂತ ಕ್ಯಾರಿ ಔಟ್ಪುಟ್ both were given to OR gate, and this was equal to sum and this was equal to carry, right? ಅದೇ ತರ ಬರೆಯೋಣ. So this is the sum part. This will be again given to another XOR gate to generate a sum where one of the input will be the Cin. Clear? So either the sum part, let me call it as S1. Either the carry part, let me call it as C1. Some part of the first half adder will be given as one of the input for the second half adder, and Cin will be given as the second input for the second half adder. That's what we have done over here. So ಇದಕ್ಕೂ ಒಂದು ನನಗೆ ಕ್ಯಾರಿ ಪಾರ್ಟ್ ಬರ್ಬೇಕಲ್ವಾ. ಸೊ ಈ ಕ್ಯಾರಿ ಪಾರ್ಟ್ ಬರಕ್ಕೆ this and this, that must be given to an AND gate. So the expression for this is A dot B. Clear? What's the expression for this? This I am taking from this point A XOR B dot, because this is the AND gate. This is one of the input. A XOR B is one of the input, and E wire yavadu that is Cin. So A XOR B dot Cin. This is another input. So what we are going to do now, illinda barthare first half adder carry as well as second half adder carry, both will be given to an OR gate in order to get the output carry of a full adder. So this is the carry part of a full adder. This is the sum part, whereas this is the carry part. Now let us try to write the expression in terms of this diagram. In diagram prakara, this is A XOR B and this is C in. If A and B are the two inputs for an XOR gate, then we are going to write it as A XOR B. Clear? Now for this XOR gate, A XOR B is one of the input and C in is another input. So the expression will be A XOR B XOR C in. I hope you are getting. Now, this is the output for which I have to write the expression now. So, carry expression ಏನಾಗ್ತದೆ ಇವಾಗ? So, for this carry, one of the input is A dot B. The other input is A XOR B C in. Here, this is an OR gate. So, ಎರಡು expressions ಮಧ್ಯ ಎರಡು elements ಮಧ್ಯ ಯಾವ symbol ಬರಿತೀವಿ ನಾವು? Plus symbol ಬರಿತೀವಿ. So, A XOR B C in plus AB is the expression for the carry part. So, now we have to compare these expressions using this truth table. ಈಗ truth table na ನೋಡ್ಕೊಂಡು ಅದು ಇದೇ ತರ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತಾ ಅಂತ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. To construct one full adder, we are going to use 2 XOR gates, 2 AND gates and 1 OR gate. Clear? Coming for the expressions to be derived from the truth table, this is what is the expression what we got from the this thing diagram using logic gates. ಇವಾಗ ಟ್ರೂತ್ ಟೇಬಲ್ ನಿಂದ ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಡಿರೈವ್ ಮಾಡೋದು, ಅಲ್ಲಿಂದ ಬರುವಂತ ಎಕ್ಸ್ಪ್ರೆಷನ್ ದಟ್ ಹ್ಯಾಸ್ ಟು ಮ್ಯಾಚ್ ವಿತ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ನಾವು ಐ ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್ ಯು, ಎಲ್ಲೆಲ್ಲಿ 1 ಇರುತ್ತೋ ಅದನ್ನ ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. Wherever the output value is equal to 1, only that combinations of inputs must be considered. Whenever I am going to come across with 0, I have to write it in the complemented form. Where 1 is there, I have to write it in uncomplemented form. So this is the first combination of the sum. First sum ಅನ್ನು derive ಮಾಡೋಣ, ಆಮೇಲೆ carry ಅನ್ನು derive ಮಾಡೋಣ. So sum part. Here this is the first combination. A value is 0, B value is 0, whereas C in value is equal to 1. So 0 ಇರೋದನ್ನ complemented form ಅಲ್ಲಿ ಬರಿಬೇಕು, 1 ಇರೋದನ್ನ uncomplemented form. A bar, B bar, C in. Clear? Next, the second expression is this, plus A bar, B, C in. Clear? This, plus A, B bar, C in bar, right? And this one, C bar miss, sorry. And the last one, plus A, B, C. Clear? C in, sorry, C in. Now, let us try to take the common factors. This and this. In between these two, C in is common. Then within bracket, I am going to write A bar, B bar plus AB. Clear? Between these two expressions, I am going to take C in bar as the common factor. Then what do I get within the brackets? A bar B plus AB bar. Hota the expression for XOR gate is, if A and B are the two inputs, then the output will be A bar B plus AB bar. This now already derived ಮಾಡಿದೀನಿ. The expression for XNOR gate, if A and B are the two inputs, then the expression will be A bar B bar plus AB. ಈ ತರ ನಾವು ಬರೀತೀವಿ. And in the shortest form, we are going to write XOR as A bar B, XNOR as A bar B whole bar. Clear? Now, if I look at this and this expression is same. So C in A XOR B whole bar. Bariboda? A bar B bar plus AB anta ide. So in that place I am going to write A XOR B whole bar plus C in bar bracket nalli A bar B plus AB bar. The same thing is here. That will be written as A XOR B. Hota na? Now, if I consider this entire thing as A and this entire thing as B, entire thing antandre element na matra. If I consider A as C in, ಬೇರೆ ಎಲಿಮೆಂಟ್ ನ ತಗೊಳ್ಳೋಣ ಇಲ್ಲಾಂದ್ರೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. If I consider C in as X and A XOR B as Y, this as X and this as Y, ಇದು ಯಾವ ಥರ ಇದೆ? X Y bar plus X bar Y ಈ ಥರ ತಾನೇ ಇದೆ. ಸೊ ಇದನ್ನ ನಾವು ಹೇಗೆ ಬರಿತೀವಿ? X XOR Y ಅಂತ ಬರ್ತೇವೆ. Where X is C in, Y is A XOR B. So when I'm going to combine C in XOR A XOR B, or I can rearrange it as A XOR B XOR C in, which is same as the expression what we got from the logical diagram. So carry part at bandaga, again there are 4 different places where I am going to get output as 1. This is the first case. So carry expression will be equal to first case A bar B C in plus second case is this plus A B bar C in plus this is the next case A B C in bar, correct? Next this plus A B C. Hota hai? Now what you have to do is let me write it as C in. So what we have to do is in between these two AB is common and in between these two C in is common. Let us take C in as the common factor and write the expression A bar B plus AB bar within the brackets. If I take C in as the common factor between these two elements, then A bar B plus AB bar. Next, if I take AB as the common factor over here in between within the bracket I am going to get C in bar plus C in. Hota na? There are some of the rules what we were using in first year for solving the Boolean expressions. A plus A bar value is equal to 1. So A ಜಾಗನಲ್ಲಿ ಇಲ್ಲಿ ಏನಿದೆ C in ಅಂತ ಇದೆ. A plus A bar ಅಂತಂದ್ರೂ ಒಂದೇ, A bar plus A ಅಂತ ಹೇಳಿದ್ರು ಒಂದೇ. So in place of A I am having C in, so this entire value is equal to 1. So leaving that I am left with C in A bar B plus AB bar plus AB. Clear? So this just now I had written A bar B plus AB bar is nothing but A XOR B. So C in A XOR B plus AB, and this is the final expression what we had already got using the diagram. We have to write it in a simplest form ಅಂತ ಹೇಳಿದಾಗ ಇದನ್ನ ಸ್ವಲ್ಪ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಇದನ್ನ ಇಷ್ಟನೇ ಬರೆದ್ರೆ ಆಯ್ತು, ಬಟ್ ಕೆಲವೊಂದ್ಸತಿ ದಿಸ್ ದ ಸಿಂಪ್ಲಿಫೈಡ್ ವರ್ಷನ್ ಆಫ್ ದ ಕ್ಯಾರಿ ಪಾರ್ಟ್ ಅಂತ ಕೇಳಿದಾಗ C in of A XOR B A bar B plus AB bar plus AB ಅಂತ ಇದೆ. ಹೌದಾ? When I am going to multiply A bar B C in plus AB bar C in plus AB ಅಂತ ಇದೆ ಅಲ್ವಾ? So here what I am going to do is multiply this AB with 1 plus C. And we already know that 1 plus A value is equal to 1. So if I am going to multiply this 1 plus C with any of this, its value will not get altered because 1 plus C value is equal to 1. 1 into AB is equal to AB itself. So ಯಾವುದೇ ರೀತಿಯಾದಂಥ value change ಆಗಲ್ಲ. So A bar B C in plus AB bar C in. Now I am going to multiply this AB plus ABC. AB into 1 is AB. AB into C is ABC. Right? We also having another rule. So what is that rule? A plus A is A itself. ಎ ಬಿ ಸಿ ಇದೆ, ಅದ್ರ ಜೊತೆ ನಾನು ಇನ್ನ ಒಂದು ಎ ಬಿ ಸಿ ಇನ್ನ ಎರಡು ಸರಿ ಎ ಬಿ ಸಿ ಬರೆದ್ರು ಇಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಆಲ್ಟರ್ಡ್. ವಾಟ್ ಈಸ್ ದಿಸ್ ಪ್ಲಸ್? ಪ್ಲಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆರ್ ಗೇಟ್. ಇಫ್ ಎ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ವೆನ್ ಬೋತ್ 0 ಪ್ಲಸ್ 0 ಪ್ಲಸ್ ಆರ್ ಗೇಟ್ ಟ್ರೂತ್ ಟೇಬಲ್ ನೆನಪಿರ್ಬೇಕು. 0 ಪ್ಲಸ್ 0 ಅಂತ ಹೇಳಿದ್ರೆ ಔಟ್ಪುಟ್ ಇಸ್ 0. ಇಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ನಾಟ್ ಗೆಟಿಂಗ್ ಆಲ್ಟರ್ಡ್. ನಾನು ಇನ್ನೂ ಒಂದು 0 ಹಾಕಿದ್ರು ಇಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಆಲ್ಟರ್ಡ್. ಇಫ್ ಎ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಪ್ಲಸ್ 1 ಪ್ಲಸ್ 1 ಪ್ಲಸ್ ಎಷ್ಟು ಸರಿನಾದ್ರೂ ಮಾಡಿ output value will be equal to 1 itself. So its value will not get altered. So what I am going to do is a bar b c in plus ab bar c in plus ab plus abc ಅಂತ ಏನಿದೆ ಇನ್ನೊಂದ್ಸರಿ abc ನ ಬರ್ಕೊಳ್ತೀನಿ. I mean to say c in ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. I'll forget writing the c in. c in abc in abc in ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ ಆಯ್ತಾ. So what we are going to do is in between these two I am going to take b c in as the common factor. ಇವೆರಡರ ಮಧ್ಯ ಇದು ಮತ್ತೆ ಇದೆರಡರ ಮಧ್ಯ b c in a common factor ತೆಗೆದ್ರೆ within the bracket I will be left with a bar plus a. Clear? Now I am going to compare these two expressions. Then if I am taking a c in as the common factor, within the brackets I'll be left with b bar plus b and I'm left over with this particular expression. Adanna hage barkoತೀನಿ. I already know that a bar plus a irbodu, b bar plus b irbodu, c bar plus c or z bar plus z, its value is equal to 1. How is that? Again plus anta ಹೇಳಿದ್ರೆ or gate ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೆ. So a bar plus a value or b bar plus b value or z bar plus z value is equal to 1 itself. So this thing will be equal to 1. ಇದು ಮತ್ತೆ ಇದು ಎಲ್ಲ 1 ಆಗುತ್ತೆ. So we are left with the carry part expression. We are left with bc in plus ac in plus ab. This is the simplified version of the carry expression of a full adder. ಅದನ್ನ rearrange ಮಾಡಿದ್ರೆ ab plus bc in plus ac in is the expression for the carry. Clear? So this is how you are going to realize full adder using two half adders. So ಒಂದು half adder ನಲ್ಲಿ ಒಂದು XOR gate ಒಂದು AND gate ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. When we are going to realize a full adder using two half adders, then we need two XOR gates, two AND gates and one OR gate. And I hope you are very much clear about this. If you are having any doubt, please do contact me. So this is the end of the video. We'll come up with a new video. Until then, take care. Bye.